Okay, sample problem for sag correction. A 100-meter steel tape weighing 0.4 kilograms is used in measuring a 2,000-meter line. It is supported at its ends and at 15 and 45 meter marks. If a pull of 5 kilograms is applied, determine the following. A. The cross-sectional area of the tape in square centimeters, given the steel weight density to be 7,850 kilograms per 1 cubic meters. B. The sag or the correction due to sag for every unsupported distance that is between 0 to 15 marks, 15 to 45 meter marks, and 45 to 100 marks. Letter C. Determine the total correction due to sag for one tape length. And D. The total correction due to sag for the measured distance. And E. The true length of the measured line. Okay, so we will write the given first. Okay, so we have the weight of the tape, which is 0.4 kilograms. The D, or the measured distance, to be 2,000 meters. We have also the applied pull, which is 5 kilograms. And of course, we have the nominal length of the tape, NL, which is 100 meters. Okay, by the way, so there is still a given here, the steel weight density or the weight density of the steel, which is denoted as gamma, and that is equal to 7,850 kilograms in every cubic meter. Okay, so 1 cubic meter or m cube. Okay, so for part A, what is the cross-sectional area? Okay, the cross-sectional area in square centimeters. Okay, so we know that area, okay, or the cross-sectional area of the tape is equal to the unit weight, okay, unit weight of tape divided by the weight density of the steel, no? Because the tape is made of steel in this problem. Okay, so using our variable that we discussed in our previous lesson, unit weight of the tape is omega, okay? And the weight density is equal to gamma. Okay, so we have the unit weight, okay? But the problem only give us the total weight or the weight, the W, okay? However, we know that, okay, but we know that the unit weight can be computed by the total weight of the tape divided by, okay, divided by the nominal length of the tape. Okay, so substituting this one, okay, so let me say this is your equation 1 and this is your equation 2. So we can also say that the cross-sectional area of the tape is also equal to weight or capital W divided by, okay, that is NL, okay, NL times the gamma. Okay, so in other words, if you don't have the unit weight, if the problem does not indicate the unit weight of the tape, so you have to use the weight, and then you can apply this formula now. So let me write it. So you have weight of the tape divided by the NL or the nominal length of the tape times the density of the tape. Okay, so this is also another formula for solving the cross-sectional area of the tape. Okay, expressed in terms of the weight and the length of the tape, and of course the steel weight density. Okay, so substituting, we have area is equal to, what is the weight? Weight is 0.4 kilograms and NL is 100 meters. And what is the weight density? Weight density is 7,850 and the unit is kilograms per cubic meter. Okay, so I intentionally write the units here so that you will not be confused, no? Okay, so we have here the meter will be cancelled out and then leaving here 2. Of course, kilograms will be cancelled out, then leaving the square meters. Okay, so we have area is equal to into centimeters. So we know that in 1 meter there are 100 centimeters. Okay, so this is squared, so we have also to square that one. Okay, so this will be cancelled out now, and then leaving as the square centimeters. So we have area therefore is equal to 0.0051, then the unit is square centimeters. Okay, so this is the cross-sectional area of the tape. Okay, so we already solved the cross-sectional area of the tape in square centimeters. Now we will solve the correction due to sag for every unsupported distance. Okay, so let me illustrate first the problem. Okay, so we have here the 0 mark. Okay, so here, and then of course we have the 100-meter mark. Okay, so based on the problem, it is being held or supported at 15 and 45. Okay, so we might have, okay, let me draw first. Okay, so it is being held at 15. Okay, this is 15-meter mark. Then at 45. Okay, so this is 45. And then of course at its ends. We know that the formula for sag correction is CS is equal to the unit weight squared L cube over 24P squared. Okay, if we substitute W or the omega in terms of the weight of the tape, we will get this value, no? So capital W over 24P squared, and that is times L. Okay, so I prefer to use the second one, okay, because I already have the W. Okay, however, in this example, the weight is not equal to the 0.4. Why? Because actually this formula represents the correction between unsupported distance. Okay, so in other words, if I have unsupported distance here, so I have L1 here. Okay, this is also my L2 unsupported distance, and this is my L3. So same thing, I have also the weight between this support. Okay, so let me call that one as W sub 1. The weight between 15 and 45 to be W2. Then the weight between 45 to 100, say W3. Okay, so same thing, of course, the applied pull is same, which is 5 kilograms. Okay, however, yung sag correction natin is tatlo din. So we have sag correction for the first unsupported distance, then the second between 15 to 45, and between 45 to 100. Okay, so let me also call the sag correction to be the CS sub 1 also. Okay, correction between 0 to 15, and then I will also call CS sub 2 for the correction between 15 to 45, and sag correction between 45 to 100 to be CS sub 3. Okay, so this is basically the requirement. Okay, so this is actually your CS sub 1, this is the CS sub 2, and this is the CS sub 3. Okay, so we have here CS sub 1. Okay, so this is the sag correction between 0 to 15. Okay, 0 to 15 meters. So basically that is letter I in our problem. Okay, so we have, okay, so CS sub 1 is equal to, we have W squared, this is also sub 1, and then you have L1 divided by 24p squared. Okay, so what is, we already have the value of L1. Okay, L1 here is equal to 0 to 15, of course that is 15 meters. Okay, and then the W sub 1, okay, is equal to, okay, so of course W sub 1 can be computed through ratio and proportion, right? So we have W sub 1 is to the L1, okay, and then equal to total, the weight of the tape divided by 100. Okay, so we have this value, and then of course the 100, leaving us or giving us, that is 15 times 0.4, okay, divided by 100, and W sub 1 is equal to 0.06. This is in kilograms. Okay, meters, and this is meters. Cancel out meters, leaving the kilograms. For W sub 2, okay, so for W sub 2, we will first solve the weight per support. Okay, so W sub 2, that is 15 or 45 minus 15, so of course that is 30, times the total weight of the tape, okay, that is 4, and divided by 100 will give us 0.12 kilograms. And then of course W sub 3, this is the weight between 45 to 100, that is 100 minus 45, so you will have 55 times 0.4 kilograms divided by 100, give us 0.22 kilograms. So to check, the summation of the weights here should be equal to 0.4. Okay, we have 2 plus 3. Okay, so we know that this is 0.4. Okay, 0.4, is it equal to, we have 0.06 plus 0.12 plus 0.22. Okay, so we have 0.4, 0.4. Okay, so meaning to say the weight per support is properly computed. Okay, so we have weight 1. Okay, go back to the I. Okay, so substitute the values. We already have the WI, which is 0.06. Okay, so we have 0.06. This is in kilograms, then squared times the, okay, so 0.06 squared times L1. What is L1? L1 is this support. So you have times 15. That is in meters. Okay, so let me put a division here. Okay, my pen is not working. Okay, so we have 24, then the applied pull is 5 kilograms squared. So you have 5 kilograms then squared. So what will happen is the kilograms squared will be cancelled out, okay, and then leaving us in meters. So this is the sag correction between the support 0 to 15 meters. Okay, so this is the answer for I. Okay, so for 2I, okay, 2I is basically the sag correction between 15 and 45 marks. Okay, so we denoted that one as CS sub 2. Okay, so we have CS sub 2 is equal to W sub 2 squared, L sub 2, and 24P squared. Okay, we already have the W sub 2, which is 0.12. Okay, so substitute the values. We also know that L sub 2 is the length between 15 and 45. So of course 45 minus 15, that is 30. So substitute the values. We have 0, okay, 0.12. So I will no longer write the units because it's already shown here. Okay, so we have squared and the L sub 2, that is 30. And we have 24 times 5 squared. Using the calculator, we have 0.12 squared times 30 divided by 24 times 5 squared. That is 0.12372. Okay, 0.00072 meters. Okay, that is the CS sub 2 or the sag correction between 15 and 45 meter marks. Okay, so for CS3, okay, that is a sag correction between 45 to 100. So of course, we have W sub 3 squared L3 divided by 24 times P squared. We know that W3, we already computed that, which is 0.22 kilograms. And of course, L3 is the distance between 45 to 100. That is equal to 55 meters. Okay, so that gives us 0.0044 meters. Okay, so this is the sag correction between 45 to 100 meters. Okay, so to summarize, we were able to solve the sag correction between supports. Okay, so it is still between supports. We have CE sub 1, CE sub 2, and the CE sub 3. Okay, so for item C, total correction due to sag for one tape length. Okay, so what we did a while ago is still the correction between supports. No, it's not yet the total tape length. Okay, essentially we need the correction per tape length. Okay, and then to get the correction per tape length, we need the correction per support. Okay, so that is what we did in item B. Okay, so let me write here. So we have C. Okay, this is the total correction for SAG for one tape length. Okay, so let me call that one as the CS tape length. Okay, so we have CS tape length or one full tape length. It is equal to the correction between 0 to 15 plus 15 to 45 plus 45 to 100 meters. Okay, so we have CS sub 1 plus CS sub 2 plus CS sub 3. Substituting the values, we have CS sub 1, that is 0.1239496 plus 0.072, and then you have plus 0.1244, and then it give us value of, you have 0.1239496 plus 12372 plus 0.1244, then give us a value of 0.0052. This is in meters. Okay, we have CS 1 tape length. Okay, so this is the answer for C. Okay, so for item D, the total correction due to SAG for the measured distance. Okay, so that is, we have D and we have CS correction total, that is equal to the correction per tape length. Yep, correction per tape length. Then times the number of tape length. No? So we recall that our previous formula. No? Number of tape, correction per tape length times the number of tape lengths. So how to compute the number of tape lengths? No? So of course that is the total distance, which is 2000 divided by the length of the tape or the nominal. So you have 2000 divided by the nominal tape length, which is equal to 100, and then it give us 0.104 meters. Okay, so this is the CS total, okay, or the correction of the measured distance. Okay, so next is, what is the true length of the line? Okay, measured line. Okay, so we will use this value because this is the correction of the measured distance already. So we will use this value. Okay, so we have E. Okay, so we know that we will call D prime as the corrected distance. And we know that corrected distance is equal to the measured distance, that is plus the CS total. Okay, so substitute the value. We have 2000 plus, okay, CS total. So what is the sign of the CS total? So we know that the sag correction is too short. Now, we'll make the tape into too short. Okay, and this is measurement. Okay, so when the tape is too short and the process is measurement, the sign of the correction is negative. Okay, so therefore you have negative 0.104, and then therefore the total or the corrected distance of line is equal to minus 2000. Then you have 199 or 1999.896 meters. Okay, so this is the corrected distance for the measured length. Okay, so let me summarize. So first, we were able to compute the cross-sectional area in square centimeters using the formula, that is unit weight of the tape divided by the weight density. However, we don't have the unit weight of the tape, so we express the cross-sectional area in terms of the weight of the tape and the nominal length of the tape. Okay, next is we computed the sag correction between unsupported distance. Okay, this is necessary in order for us to solve the correction per tape length. Okay, why we need to solve the correction per tape length? Because in order for us to solve the total sag correction of the measured distance. Okay, once we know the total correction of the measured distance, we will solve, or we can solve, the corrected length of the measured line. Okay, so usually in the board exam, no, this process or this question for B is not usually asked. Okay, you will be asked rather on the total correction. Okay, usually you will be asked this one. Okay, so if you directly use the formula, this one, okay, directly use this formula, and then the problem is you have different supports in the between of the end points of the tape, then it will lead you a wrong answer. Okay, so that is why, this problem actually is illustrating you if you have the this situation wherein there are several supports in between the endpoints of the tape. Now, on how to solve the total correction of the measured line, okay, to get the true length of the line. Okay,